Hello friends, this video on structure of atom part 28 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 27. Let's discuss the principal quantum number which I have told for any orbital we have 3 quantum number n, l, m, n. Let's discuss this quantum number. The first is the n, and this guy is called principal quantum number whose value can be 1, 2, 3, 4, so on. It's a positive integer. This determines the size and to large extent energy. Please note, this solely will not determine energy, but this has a contribution to determine energy of the orbital. But this determines size of the orbital. The hydrogen and hydrogen-like species, right? Energy and size depends only on n. Only for, please note, this is only for hydrogen and hydrogen-like species, which is only one electron. So the energy and the size depends only on n, but for the multi-electron, energy depends on n plus L also, which we'll learn now. And the principal quantum number also identifies the shell. As I told, shell is something which is given by the principal quantum number. When I'm saying 1s, 2s, 2p, 3s, 3p, 3 like that, these numbers gives the principal quantum number, gives the shell. And you will see that now in the next slide, the shell is further broken into subshells, and then subshells are broken into orbitals. But it is the principal quantum number which identifies the shell, whether the shell 1, shell 2 or shell 3. With the increase of the value of n, the number of allowed orbitals increase, and is given by n square. Please note, for a given value of n, for a given principal quantum number n, the number of orbitals for that will be n square, and the maximum number of orbitals or maximum number of electrons in that shell will be 2n square, because one orbital will have 2 electrons, right? So for a shell n, the number of orbitals is n square. Please note, for a shell n, the number of orbitals is n square, and subshell is also actually n. We'll tell you why. For a shell n, there are n subshells and there are n square orbitals, and there are 2 n square electrons in that, because one orbitals will have 2 electrons, correct? So for nth cell, there are n subcells and there are n square orbitals and 2 into n square electrons. For example, n is equal to 4, right? So there, fourth shell, you have 4 subshells, 4 square, that is 16 orbitals, and 2 into 4 square, that is 32 electrons. So fourth cell will have 4 subcells and 16 orbitals and 32 electrons. That's how it is. Well, if you are getting confused, just hold on. We'll have slides where the doubts will be clear. All the orbitals of a given value of n constitute of a single shell of atom. Example, n is equal to 1, shell name is K, n is equal to 2, shell name is L, n is equal to 3, shell name is M. Shown. Size of the orbitals increase with the increase in principal quantum number. That means the electron will be located away from the nucleus. So I think I showed you the diagram where this is my first cell, second 2 SL, and then this is my P cells like that. And then again you have one more S cell. So if you see, the size of the orbitals is increasing, right, with the increase in quantum numbers. This is 1, for this quantum number is 2, here the quantum number is 3. For all these 3, if you see the S, they are all S, but the size of the orbitals increase. Since the energy is required in shifting away the negatively electron from positively charged electron, the energy of orbital will increase with increase in principal quantum number. So the energy will increase. So if I say the fourth shell will have more energy, third will have less energy, 2 will have less, 1 will have less. That's why if you see, this guy gets filled first, then this guy, then this guy. M will explain more in detail. Next slide. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.